Hello everybody, how are you today? Today we are going to talk about physical and chemical properties. So everything around us or any element around us can be classified into two groups like metals and nonmetals. So as you can see here, we have here the students, okay? So we can put them in a group. We put the girls in a group and the boys in a group, right? But here we have different elements like copper, like iron, like silver, like carbon, like coal. All of them they are elements. So how we can classify them? We can classify them by putting them in a group which is metal and non-metal, depending on what? Depending on physical and chemical properties. So the easiest way to start group substance by compare their physical properties. What is the physical properties? Take a small piece of iron and copper, aluminium, and magnesium and clean their surface by rubbing with a sandpaper. And the surface becomes shiny, and the property is called metallic luster. So metallic luster, which means that the element is shiny, like the iron, like the copper, like the aluminium, like the magnesium. All of them, they are shiny, so they shine and give a luster. Hardness, metal are generally hard and cannot be cut with a knife. And the hardness varies from metal to metal. But sodium is soft and can be cut with a knife. So we said the metallic luster, when I just rub it with sand paper, it's going to be shiny. It's going to be shiny. Also the hardness, which means that the metal is very hard and very strong. Okay, I cannot cut it with a knife, but I have only one metal which is soft like the sodium that I can cut it with the knife. Malleability, which means it's the element able to be beaten into a thin sheet. I can just knock on it, or I can shape it into a thin sheet. Like the gold, silver are the most malleable metal. Ductility, which means that able to be drawn into a wires. So we have malleability, which means can be shaped into sheets, and ductility can be shaped into wires. Gold is the most ductile metal. 1 gram of gold can be drawn into wires. Due to the malleability and ductility, metal can form a different shapes. So malleability can be formed into different sheets or into sheets. Ductility can be drawn into wires. Conductors of heat, we have here aluminium and copper on a stand and fix them to the free end wire using a wax and heat the wire near to clamp place. So again, we have here the aluminium or copper, and fix them on the pan and put the end of the the wire near to the clamped place. Heat transfer to the area of the wax. It melts the wax and the pan drops, but the metal wire does not melt. It shows that the metal are good conductor of heat and have a high melting point. So when they have something like the wax, so they are connected with like a bar, so the wax is going to melt because the metal is good conductor of heat. Silver and copper the best conductor of heat, and lead and mercury they are poor conductor of heat. Okay, again we have here the metal, and while we are heating the metal, so the end of the wax is going to melt because this metal, the metal wire, conduct the heat. Conductor of electricity, set like a circuit like here, and place a metal in a circuit between A and B. We put here a piece of wire, so it indicates that the metal are good conductor. So the wire carry out the current of the rubber-like materials, and they are insulated to prevent electric shock. So again, the wires that carry currents have code. It's called a PVC, which means polyvinyl chloride, all rubber-like materials. They are insulated to prevent electric shock. Sonority, which means ability to produce sound on striking hard on them. Metal are sonorous, and so they used to make bells. So again, conductor of heat, which means they can conduct the heat. They can conduct the heat. So we have here the metal wire can be shaped into how to form, it can conduct the heat. Also, we have the conductor of electricity. If we put like a piece of the metal in the terminator or in the end A and B, so we find that the lamp lights up. So, which means that it can conduct electricity. We have sonority, which means the ability to produce sound if you knock on their surface. Okay, but there are a few numbers like carbon, silver, iodine, oxygen, hydrogen. So we have different things. So we have something we breathe. We have something we breathe out, like carbon dioxide. We have different kinds of things around us. So can people put them into two parts, like metal and non-metal. We have here the only a few non-metals have physical properties of metal. Only few of them. We have here graphite, coal, silver, and iodine. Okay, all of them they are not malleable or ductile because they are non-metal. Sonority, but the only one that conducts electricity of non-metal, which is graphite. So graphite is the only non-metal that conducts electricity. The only one which is non-metal and has a luster, like iodine. Physical properties, we cannot group the element based on physical properties, as they have many expectations or many exceptions. Metals except mercury are solid at room temperature. All of them liquid except the mercury, liquid at room temperature. Metals have a melting point, but gallium and cesium very low melting point, and they melt if they just put or keep them on like cesium and gallium. Once you are putting them in your hands, so they are gonna melt. Iodine is non-metal, but it has a luster. Carbon is non-metal, but it conduct electricity. Diamond is the hardest natural substance, and they have a very high melting point and boiling point. Graphite is conductor of electricity. So carbon is non-metal that exists in different forms. Allotropes. Graphite can conduct electricity. Metals like lithium, sodium, and calcium, they are soft and they cut with a knife, and they have a low density and low melting point. So again, all the metal, they are solid in the room temperature, but only mercury, or except mercury. Metals have high melting point, like gallium and cesium, but they have a very low melting point once you put them in your palm, so they are gonna melt. Iodine, they are non-metal that has a luster. The only non-metal that has a luster, which is iodine. We have cesium and gallium, they have a very low melting point. Diamond, which is the hardest metal, that has a very high melting point and very high boiling point. We have here carbon, they have a lot of forms, or present in or existed in different forms, which is called allotropes. Metals like lithium, sodium, calcium, they are soft, and I can cut them with the knife. So I talked about the physical properties, which is the properties I can observe it with my eyes or maybe by my 5 senses. Okay, now I'm gonna talk about the chemical properties. So element can be more clearly classified into 2 groups, or classify according to: burn the magnesium ribbon and collect the ash. So we have magnesium ribbon, so it forms magnesium oxide. Taste the solutions with a red or blue litmus paper. So the red litmus paper become blue, which means this one is basic. So magnesium hydroxide, which is basic because it turns into blue. We have silver, and I'm gonna to collect the fumes of SO2 by placing a test tube, burning the silver, add some water to it. It produces sulfuric acid, and then test it by litmus paper, so it will change into red. Okay, so most non-metal produce acidic oxide. Dissolve in water. Most metal produce basic oxide. يبقى الميتال non-metal produce a basic acidic oxide, but the metal produce basic oxide. Basic oxide يبقى metal basic, non-metal acidic. What happens when metal burn in the air? Try to burn a various metal like aluminium, copper, iron, lead on a flame. Sodium burn easily with a yellow fume. So we have here sodium burn easily with a yellow fume. Magnesium produce like a white fume. Copper produce blue and green. Aluminium produce a white. So the metal surface appears silver or white after burning it. Metal surface, تمام. So reactivity of the metal to the oxygen decreased by order. So we have sodium, magnesium, aluminium, zinc, iron, lead, copper. So according to their arrangement, so we have the strongest one, which is sodium, and then magnesium, aluminium, zinc, iron, lead, and copper. One of the products of the metal oxide, sodium oxide, is soluble in water, and other metal oxide are insoluble. Metal oxide are soluble in water, and other metals are insoluble. What happens when a metal burn in the air? So almost all metals combine with oxygen and form metal oxide. And when copper is heated in the air, it forms a copper dioxide. Similarly with aluminium, it forms the aluminium oxide. So when the metal burns in the air, form a metal oxide. Okay, so metal oxide are basic. We said the metal are basic. Metal are basic. But some of the metal oxides, such as aluminium oxide, zinc oxide, they can form both, or they have the two behavior, like acidic and basic behavior. Such metal oxide, which react with the acid and base and produce a salt and water, and called amphoteric oxide. So some of them, like aluminium, zinc, they show the both kind of behavior. They show that they have acidic and basic. Most metals are water soluble. You said they form a basic behavior. Most of them, they are water soluble. Once I put them in the water, they are gonna dissolve in water, like sodium oxide and calcium oxide. All metals show different reactivity toward the oxygen. They have like different behavior. Metals such as potassium and sodium, they act vigorously, very strongly, and they cause a fire. So hence we keep them under the kerosene ion. What happens when a metal burn in water again? We said it forms a metal oxide. At ordinary temperature, surface of magnesium, aluminium, zinc, lead are covered with a thin protective layer of oxide. We said for sodium and the calcium, because they are very, very reactive, so we covered them under the kerosene ion. What about for magnesium, aluminium, covered with a layer of oxide? It prevents the metal from further oxidation. Iron does not burn by heating, but iron filings burn very vigorously when sprinkling into the flame. If I put the iron filings, which is have a lot of surface area, so once I get it closer to the fire, so they are gonna to burn in a vigorous way. So but if it's like a piece or a part of iron, so it will not make a reaction like this. Silver and gold, they not react with oxygen at very high temperature. So the one that react with the oxygen, like as potassium and sodium, and also magnesium, aluminium, zinc, they react, but not in a vigorous way as the sodium and magnesium. We have here the silver and gold. They like I can say that they have weak metals. They do not react directly with oxygen. Okay, yeah, stop here. Okay, so next time we are going to continue this PowerPoint, inshallah.